You know, in our world today, data isn't just about how big it is, it's about how connected it is. From your social network to a global supply chain, the real juicy insights are hidden in the relationships between all those data points. In this explainer, we're going to unlock the power of the technology that's built specifically to understand that crazy web of connections, the graph database. So let me start with a question for you. What do your friends, that thing you just bought online, and a massive global supply chain all have in common? I mean, they seem totally different, right? But believe it or not, they all share one fundamental secret.
It's all about the connections, the relationships between people, between you and a product, between a supplier and a factory. That's where the most important stories are being told. And to understand those stories, well, you need a special kind of tool.
So here's our game plan. We'll kick things off with the big problem that traditional databases run into. Then we'll introduce the solution, the graph database. We're going to dive into how they think, check out some amazing real-world examples, and finally ask the big question: is a graph always the best answer? All right, let's jump right into the main challenge here, the data web problem. We're talking about why the kind of databases that most of the world was built on are really starting to show their age. For decades, we've organized data in these nice, neat tables, right? Think of a spreadsheet with clean rows and columns, and that's perfect for a lot of things. But what happens when your data looks less like a neat grid and more like a tangled web of connections? That's where the old school systems just hit a brick wall. And the pain points are super specific. To connect data between different tables, you have to run this operation called a join. Now, if you need to find friends of friends of friends, you're doing join after join after join. And these things get computationally expensive, fast. Your whole data structure gets rigid, it's hard to change, and pretty soon, your performance just falls off a cliff. But what if a database was designed from the ground up, specifically to handle that tangled mess? Well, that's where we get to meet the hero of our story, the graph database. Now, the most important part of this whole slide is that last phrase, treating relationships as first-class citizens. In a traditional database, relationships are kind of an afterthought, something you have to calculate on the fly. In a graph database, the relationship itself is just as important as the data it's connecting. And it all boils down to three really simple building blocks. First, you've got nodes. These are the things, like a person or a product. Second, you have edges. These are the relationships that connect the nodes, like friends with or purchased. And finally, you have properties. These are just the little details, like a person's name or age, and that's it, the whole shebang. So here's the absolute key takeaway. Instead of calculating a connection with one of those expensive joins, a graph database stores that connection physically. It's not a calculation, it's a fact that's already saved, almost like a direct pointer from one thing to another. This, right here, is the fundamental superpower of a graph. And that brings us to our third section, how graphs think. Let's really see how this superpower turns into unbelievable speed and clarity when you start asking really complex questions. I love this analogy. It's perfect. Querying the old way is like getting a long list of written directions. Okay, go to the users table, turn left at user ID 123, then go to the friends table, find the matching ID, then go to the purchases table. It's exhausting. A graph database is like a GPS. You just tell it where you want to go, and it instantly shows you the fastest path to get there. And here's what that actually looks like. On the left, you see the old way with all those complicated joins. On the right, though, the graph query is almost like drawing a picture. It basically reads like a sentence. Match a person named Alice who is friends with another person who then purchased an item. It's intuitive, it's elegant, and because you're just walking along a pre-existing path, it is unbelievably fast. Okay, so that's the theory, but let's see how this stuff actually works out there in the wild. Where are graph databases making a real difference right now? So one of the most powerful uses is in fraud detection. I'm serious. Financial institutions will build these massive graphs of transactions, accounts, and devices. This lets them instantly spot suspicious patterns, like money moving in a perfect circle or taking a really weird, complex path, things that would be almost impossible to find in a bunch of tables. You ever wonder how a shopping website knows exactly what you might want to buy next? Well, a lot of the time, that's a graph at work. They connect you, your friends, the products you look at, the things you buy, And this makes it super easy to find these powerful recommendations like, hey, people in your network who bought this camera also bought this lens. And the applications just keep going. Graph databases power the huge knowledge graphs behind AI and search engines, helping them actually understand the relationships between concepts. They're also essential for managing things like complex supply chains or massive computer networks, because you can model all the dependencies and prevent problems before they start. Now, with all this power, you might be thinking, wow, graphs are the solution to everything. But like with any technology, the real key is knowing when to use it. And that brings us to our final section. Is a graph always the better choice? It's the obvious question, right? If this tech is so great, why don't we just replace all our old databases with it? And the answer is a very clear, not always. Graph databases are specialists. They are the absolute champions when your problem is all about the connections and relationships. Look, if your data is just a simple, flat list with very few relationships, like a list of contacts, a traditional database is probably simpler and totally fine. Or if you need to do bulk analysis, like calculating the average of every single sale you made last year, a relational database is still the better tool for the job. Graphs are for following paths, not for scanning every single entry in a giant table. Which brings us to the key takeaway. Our world is built on connections, and it's getting more connected every single day. To make sense of it all, to find those hidden patterns and insights, we need tools that are actually built to understand those connections. And that, right there, is the essential role of a graph database. So if you only remember 3 things from all this, make it these. 1. Graph databases see the world as nodes and edges, the things and the relationships between them. 2. They're so fast because those relationships are stored directly. And 3. This is what lets them unlock incredible insights in everything from catching criminals to recommending your next favorite movie. We've used graphs to understand our social networks and our financial systems. But as our world gets even more connected, even more tangled, what are the next crucial relationships we're going to need to map out and understand? What new problems will we solve by focusing not on the things themselves, but on how they're all connected? That's the question this technology really leaves us with.